The Mekong. Situated in Southeast Asia, the Mekong River flows through 6 countries. For centuries, the river has offered a valuable source of water, food, and energy, and has provided a vital channel of communication between riparian communities. The Mekong River is not only a valuable natural resource, it also has extensive natural navigation potential. Waterborne transport on the river has served as one of the main modes of transport between riparian communities since people first settled along its banks many centuries ago. As river traffic is comparatively cheap, safe, and reliable, navigation along the Mekong River is important for travel and trade and provides a means for people to access natural resources and social facilities such as schools and health services. In the Mekong Agreement of 1995, the Mekong River Commission, MRC, is to coordinate and promote the sustainable development of the Mekong River, including navigation. Article 9 gives MRC a specific mandate to ensure freedom of navigation in the lower Mekong Basin. In this regard, the MRC has developed a master plan, facilitated agreements, and issued guidelines relating to Mekong waterborne transport. Yet the navigation potential of this huge river is underutilized. With the exception of the Mekong Delta in Vietnam, most of the river resembles an empty highway. This is because the Mekong contains a number of serious physical obstacles, especially in its upper parts, upstream of the Cone Falls. Only experienced skippers with sound knowledge of the river, commonly passed down from generation to generation, can safely navigate the Mekong in its current condition. Their boats are small in size, shallow in draft, and no more than 45 meters in length. Nonetheless, there have been many accidents over the years, many unreported. The Mekong River from Vientiane to Chiang Saen is 791 kilometers in length. The stretch below Tong Phong is difficult for navigation as well as Phaluk. These stretches are narrow. The commercial ships and tourist ships are difficult to navigate. Last year, 2 commercial ships were sunk. Waterway improvements in the upper stretches of the river are therefore needed. However, this requires a number of physical obstacles to be removed or relocated.
There was a huge rock positioned right in the middle of the Mekong, and it swept around this rock. This is about halfway between Pak Bang and Hue Zai. Quite an interesting situation because even the authorities realized that this rock was of a huge danger. Boats coming up the river could not see further upstream than this rock, and of course boats coming downstream. So they actually positioned a man or 2 high up on the riverbank, especially during the dry season, and they would wave flags to boats coming upstream, warning them of this huge danger, this massive rock, and likewise they would warn boats coming down that there was a boat coming up.
How to achieve this goal in an environmentally friendly way? How do river engineers avoid or minimize collateral damage to important ecological aquatic systems and fish habitats when designing safe navigation channels? The first step is to carry out a detailed survey of the selected area to enable river engineers to design a cost-effective navigation pass that keeps excavation work to a minimum. Advanced survey methods are now available. While hydrographic surveys are carried out using a sonar fixed to a boat, topographic surveys above the waterline are conducted with rovers strolling over the riverbanks, measuring hundreds, even thousands of 3-dimensional survey points. The example shown in this video demonstrates. The dark blue line represents the chart datum, the red line representing the thalweg, the geometrical line at the deepest points in the river. The light blue lines showing the -3 meter water depth line on both riverbanks. The light blue colored zone corresponding to the area more than 3 meters in depth, the safety water depth for vessels and barges of 2.5 meter draft during chart datum levels. The minimum available width of the channel between the rocky riverbank and the rocky outcrop in the middle of the river, which is 23.29 meters, insufficient for safe navigation for vessels of 500 tons, Chinese barges. This example shows clearly that this short section of waterway, which does not exceed 820 meters in length, needs enlargement and the removal of part of the rocky island in the middle of the river. It also needs the demolition of a part above the waterline to create safe visibility for oncoming vessels and barges. Channel width between 40 to 45 meters appears to be the minimum safety requirement. This minimum means that a number of rock outcrops will have to be removed, demolished, and/or relocated. After finishing the design of the new channel, the physical removal of the rock has to be tackled. It is recommended that rock blasting should be a last resort, but experience teaches us that this is also often the only resort. Rock blasting is subject to a number of international rules, safety regulations, and guidelines for proper use of explosives underwater and in fisheries to eliminate or mitigate effects of blasting underwater in aquatic environments. Air bubble screens are therefore recommended to limit and reduce the propagation of shockwaves through the water. In cases where powerful hydraulic rock excavators standing on pontoons can be used, this should be the priority option. Nevertheless, rock blasting may be necessary for several reasons. Safety of the labor force. Very strong and turbulent water flows at excavation sites. Excavation of hard rock. And the long-term obstruction of the only navigation channel during the operation. The removal of an obstacle in the current of the river will have an impact on its flow. Increased flow at rapids where the obstacles have been removed will result in lowering the water table upstream and lifting the water table downstream. Such changes have to be avoided in order to protect fish habitats and aquatic life. It is therefore recommended that debris from demolition work or rock excavation be stockpiled for use in mitigating impacts to river flow. This means that hydraulic excavators on pontoons have to be accompanied by flat pontoons so debris can be stored and moved. Debris should never be stored in deep holes, as they are a preferred habitat for fish, in particular the giant Mekong catfish. The correct placement of debris in the current of the river is a prerequisite for the removal of the physical obstacle. Debris and rocks from demolition work have to be placed in well-chosen locations where they produce the same hindrance to the water flow, thereby leaving the water tables upstream and downstream of the project site unaltered. We hope this video demonstrates that improving waterways is important to the Mekong River and is an environmentally friendly way to develop water transportation in the region.